I hope my PPT is visible. Good morning, all of you. So today we are going to see the basic thermodynamics. So in the preparation, the first topic is a basic thermodynamics. Okay. So in the basic thermodynamics, we will be looking into the Zeeberg law, first law, second law, and the third law. So mostly we will be dealing with the heat transfer and the work transfer. Okay. So first, let me explain within what is thermodynamics. I hope my PPT is visible. Now first I will explain about what is thermodynamics. Now as you can see, it has been mentioned here, it deals with energy. It deals with energy in the form of heat and work, which helps to transfer into each other and effect of energy transfer on the properties of the system. Now it can be transformed in various kinds of properties, like it can be of enthalpy, it can be of entropy. So in various kinds of forms, it can be of internal energy. So the heat and work can be transformed in various kinds of properties. So that is what the meaning of thermal. That means always it begins with kind of heat and work and its property transformation. Now thermodynamics deals with three E's. Deals with three E's. The first one is energy, equilibrium, and entropy. Now energy means it can be various forms of energy, as we have discussed. The effect of energy transformation on the property of systems. I request all of you to read yourself. Now equilibrium we are having equilibrium play an important role to balance the system. It can be of mechanical equilibrium, it can be of chemical equilibrium. So again, the equilibrium play a very important role. You have to balance the system. Then entropy. Yes, entropy another the randomness. How random.
Excuse me, ma'am.
Yes.
Ma'am, actually your voice is too low, ma'am. Only half the words were able to listen. Are you able to hear me, ma'am? Hello?
Am I audible right now?
Yes, ma'am, but I guess there is some sort of background noise, some sort of disturbance from. So the voice is pretty much.
Just give me
Yes.
a minute. Just give me a minute.
Sure.
I hope it has been sorted and my voice is quite audible.
Yes, ma'am. Yes, ma'am.
Alright. So, as I have said, it deals with three E's. That is, the first one is energy, equilibrium, and entropy. Okay? Energy, it can be transformed in different kind of energies. It can be enthalpy. Alright. This is also one type of energy. Then work done. Then heat transfer. Equilibrium, it can be a mechanical equilibrium, chemical, again heat, thermal equilibrium. So again, it play a very important role. Can be of thermal, can be of chemical, can be of other, etc. Equilibrium play another important role. We have to balance the system. Entropy is the randomness, how the heat, how fast or how effective the heat transfer process are taking place, how rapidly the molecules, the intermolecular factors are moving from one point to another point. Now we have the three principles. As we have discussed, we have three principles. The first and foremost is the zeroth law. Then we have the first law, second law, and third law. Each and every law plays a very key role. So when we are talking about the zeroth law, we will be talking about thermal equilibrium. That means how the temperature is getting balanced from one body to another body. So that means mostly we're talking about the temperature, dealing with the temperature. Now when we are looking for the first law, we'll be looking about the internal energy enthalpy properties, how the energy is getting conserved. Okay? At the same time, when we're talking the energy, when a body is undergoing some kind of heat additions, how much amount of work done will be undertaken by the particular process. And inside, what is the intermolecular? When we talk about internal energy, means we are seeing the impact of the intermolecular factors. More we are looking into the microscopic level. So we will see what is microscopic level also. So the first law deals with that internal energy. In some textbook, you can find internal energy is denoted by E or U. So you can follow any one of the conventions. Second law, it is that, as I have said, how the energy is transformed.
Hello, ma'am.
Yes.
Ma'am, your voice is not clear, ma'am.
Am I not audible?
No, ma'am. Not clearly.
Not clearly in the sense, should I speak loudly or
Loudly, ma'am.
I should speak loudly? Okay.
Yes, ma'am.
Is it better now?
Yes,
Is
ma'am.
it better?
Yes, ma'am.
All right. So, second law deals with the energy transformation. Okay, how it is moving from the high to low. Okay? So again, we will see whether there are lot many theories are there, whether any engine can transfer heat from high to low. We will see about the heat pump, refrigerator, and heat engine. How these three engines are differentiated with one another. And third law is completely talking about absolute zero of entropy. Now, as I've said, we will also discuss about the thermodynamics. There are two types. One is a classic thermodynamics, and one is a statistical thermodynamics. One is deals with a microscopic approach. Another one is the microscopic approach. So mostly here we are going to see about the microscopic approach. So microscopy means more in detail with the intermolecular structures, how they're affecting, how it leads to transfer the heat and so on. Now, first when we talk about thermodynamics, we will understand what is thermodynamics background of thermodynamics. So start with that thermodynamic systems. Okay? Now, just take any random surface. As you can see here, we have any random surface. Now, when we have in particular subject or systems, okay, or particular area, so we can say a control volume. Okay, control volume means suppose we have some particular volume, you are going to analyze over this particular region of this volume. So you're creating some kind of boundary. You're creating some kind of boundary. So that control volume becomes your system. That control volumes becomes your system. Now what you do, the outlines of that particular system becomes your boundary, or we can call as a system boundary. It can be either real or imaginary. Suppose in a big mass, and if you want to find a small amount of mass from that big mass, then boundary will become an imaginary boundary. And if you want to consider the entire mass, what is existing, the same thing you're taking, that will become your real. For an example, in a in a container, okay, in a container, you have a water. Just consider you're having water in a container, right? Now, water we cannot keep it outside, right? We have to keep it in some container, and its volume will define that how much amount of water is kept on the particular container. It will define its volume. Alright. Now, when we keep the water in the particular container, that means this will become its control volume. This particular area or the volume it is occupying in the container, it will be the control volume for that. And this container outliners will be the its boundary, and the atmospheric thing whichever coming in contact with that particular surface of the water will be the surrounding. Okay, so same thing happens for any systems. Okay, for any systems. So whenever you are splitting any object, so it will have the three things: systems, and outside of the systems will be having the surroundings, okay, and that which splits between or creating an interference between the surrounding and the system is called as a boundary. System boundary. And the complete system and the complete unit, okay, complete unit we call as a universe. Complete unit when compiling with all the surface and system is called as a universe. Now we have lot many types of system boundaries. Okay? It can be of different types. What kind of boundary you are using? One can be rigid boundary, adiabatic, sorry, yes, adiabatic and diathermal. Okay, diathermal. So what that rigid means? So here you can expect a question like match the following. Match the following. Mostly in this kind of questions they ask as a match the following. So, so you should understand what are the kind of bodies. Rigid body in the sense, just give me a minute. Should we go back here? Okay. Now, rigid means when there is a change in volume in the system is restricted. That means your you have this body, you have this container, you have the water. Okay, the your control volume is not changing. That means the boundary, due to some external atmospheric surrounding or something, your boundary is not affecting. It is fixed. The volume is fixed. Okay, that time we call it is a rigid. Okay, the boundary is rigid. It is not flexible. It is fixed. Now, adiabatic, when we say that exchange of energy flow in the form of heat is restricted. That means here, when we are adding any heat, it is not getting heated up. It is not affecting into the system. It is not affecting into the system. As you know, adiabatic means the heat will be considered when the heat is zero, right? So when it is there, when we are giving an external heat in the surrounding, it is not affecting into the system. So such kind of boundary is called as a adiabatic boundary. Now diathermal boundary is something which is opposite of the adiabatic boundary, which allows the heat to pass through the boundary. Got it? So there are three types. The rigid, which does not allow to change the volume. Adiabatic, it does not allow the heat to transfer. And the third one is a diathermal boundary, which allows the heat to transfer freely into the system. Now we will look into the three types of systems. Here also in this question, you can expect to get to maybe they might give a relevant match the following, okay, or maybe they will give you the statement and to predict what are the following system are. Okay, so so it is very important to understand what are the types of systems. There are three types of system. Okay, this type of system depends on how the energy and mass are transferred. How the energy means heat, mass means whether the mass of the volume is changing or not changing. That what it depends on the type of systems. We have three types: open type, closed type, isolated type. Now when we have the open type, that means it is free to interact of the energy and the mass. That means mass can freely, if any body is there, the energy can also enter. Okay, it can move, and also the mass. Mass, there is a movement of mass. For an example, boiling of water. Okay, you're boiling of water in a container. So what you're doing, you're heating from the bottom. Okay, you're heating from the bottom. So your your the water is getting boiled up. So when it boils up, what happens? There will be a vapor formation which moves, right? So again, there is a mass transformation. So that is one of the um, example of an open system. Okay. Next, the closed system. Okay. What is closed system? Here in the closed system, only energy can interact. Okay, only energy can interact, no mass. For an example, as I've written, a biggest example you can remember is a pressure cooker. So when you put something in the pressure cooker, right? So what happened? You're heating from the bottom, and the mass cannot escape out. The mass, okay, whatever happens, it will happen within inside. The mass cannot escape outside. Okay, so such kind of systems are called as a closed system. Okay? The third one is isolated. Isolated means that neither the energy nor the mass can interact with each other. The biggest example you can remember is a thermoflask. Okay, when you keep a hot water uh, in the flask, what happens? It stays intact. Okay, it stays intact. There is a no, neither the heat is getting transferred. If the heat get transferred, means either it will cool down, right? It will cool down. The hot water will get cooled down. So neither the mass nor the energy is transferred.
Excuse me,
Okay.
ma'am.
Yes, please.
Ma'am, does thermoflask really exist, ma'am? It's completely an isolated system you're telling. Anyhow, the energy should be transferred at any point of time, no, ma'am.
Yes, if you're keeping for 3 days, 4 days, then it has to be. Now again, it will depends on. Now there are certain systems. Okay, there are certain systems where you can isolate. You can isolate the energy and mass. Okay. I hope you will be knowing the nuclear power station, right?
Yes,
So
ma'am.
in the nuclear power station, there are some reactors are there where the energy can't be transferred. Everything is happening within that particular reactors, right? Okay.
Okay, ma'am.
So that kind of examples is the isolate. It is here we're not talking with respect to time.
Okay, 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 ma'am.
Now obviously at some respective time the things will change. If you keep in the same
But
time,
I have one more doubt, ma'am. Like if a lot amount of energy is being stored in a single place for a lot of time, then more amount of stresses will be acting on that particular surrounding, ma'am. If more stress is being acting at that time, there are chances for it to be bursting also. Will that happen, ma'am?
again, it is a possibilities are there. So that's why we have to also, this is also one of the design criteria actually. Now, if you want to keep for a longer period of time, then accordingly you have to find out how much amount of heat transfer will take place in the consecutive period, because you're keeping for longer time. What will be the thickness of your chamber, what will be the thickness of your hoop stress and the circumferential stress we have to have. So that is a different again. So again you have to work more into the structural area and heat transfer. That is interdisciplinary areas. So that is another is there. Okay, that is
Ma'am,
also there.
one last question, ma'am. What is the material that's being used for the construction inside the thermoflask, ma'am? The inner part of the material, the thermoflask.
I'm not. I have to look into it. I'm not clear with that right now. Okay, I will look into that and I will tell you. Yeah, I don't want to just. I will give you the proper answer in the next session. Okay, what is that? Okay, now talking about thermodynamic properties. Okay, so as I've said, we have to remember about the properties of the thermodynamics things. So whatever the energy transform or whatever things happen, it can be transformed in two different forms. Either it depends on mass or independent of mass. That means thermodynamic property means either it has to be dependent with the mass or independent with the mass. So when it is a dependent with the mass, we call as an extensive, and when it is independent, we call as an intensive. Okay? So here again, I hope I have asked you a question. So every time in the gate, they are asking, you can expect one more question from here. So you have to remember the examples. Okay. So whenever there is some kind of specific volume, specific energy, so whenever there is something specific, so it will be comes under the intensive mostly. And you remember the pressure, temperature, density, all are the independent of the mass. But when we talk about the volume, it is mass dependent, internal energy, enthalpy, entropy, energy, okay, momentum, all these are dependent with the mass. Okay? Please remember the examples over here. That is very important. The examples are very important. Now moving to the process. Now here it is very important to understand the process. From based on the process, they ask whether it is a path function or it is a point function. So whether it is a path function and point function. So before that, you should know what is the difference between path and point. Okay. Path means process. We are talking about the thermodynamic process. That means when any heat is added into the system, okay, it might have undertaken some work. It can be work done by the process or from the process. It can be anything. So that process, okay, what is a type of process? Suppose it is changing from one state to another state. Okay, let me consider it is moving from the state 1 to 2. It is moving from the state 1 to 2. Then what will happen? I can say, if you can see the graph over here is with some property along the x, some property along the y. Okay. Now we have 2 points, 1 and 2. Now the process can be either in the first curve A, it can be B, it can be C. But we don't know which one. It can be either. Right? So there are of several processes how it is transforming, whether the temperature is constant, whether the pressure is constant, whether the volume is constant. Okay. So based on that, we have to understand what is the process. to identify the path. To identify the path, it is very important to identify the process. Okay? Now, what is the process? We have the isothermal process. Isothermal, that means same. Iso means same, thermal means temperature. So when we have the same temperature, isobaric. Iso means same. Baric means it is a one of the, the pressure is also known as a bar. Okay, pressure unit is bar. So isobaric means when the pressure is constant. Isotonic, that is when the volume is same or volume is constant. That means if you have the process 1 and 2, that means V1 will be equals to V2. V1 will be equals to V2. In isobaric process, T1 will be equals to P2, and isothermal process T1 will be equals to T2. Now comes the cycle. Now after process, how this process are moving. Okay, how this process are moving. Now, as I've shown here, some property on the X, some property in the Y. Okay, some property in the Y direction. Now, if I say the process is moving from 1 to 2, 1 to 2. So, let's consider it is a V and this is a V. This is pressure and this is the volume, not velocity, the volume. Okay, because it deals with the volume, pressure and temperature. Now 1 to 2, we have like this. 2 to 3, we have like this. And 3 to 1, we have like this. Okay, we have 3 different processes. Alright, now in this first 1 to 2, what process is that? We have the isobaric process, because both the P1 equals to P2. P1 and P2, if I put a dotted line, so both are same. But V1 doesn't mean that the V1 is not equals to V2. Now the second is 2 to 3. What is 2 to 3? We have the same volume. That means isobaric process. That means V2 equals to V3. Doesn't mean that V2 will be not equals to V3. Then 3 to 1. Can you tell me what is 3 to 1? 3 to 1.
It's isothermal now.
It's an
Isothermal process.
isothermal process. That means here the temperature T3 has to be same with T1. It doesn't mean that that means V1 is not equals to V3 and P1 is not equals to V3. So when this starts with 1, then you move to 2, then move to 3 and again come back to 1. When it is a complete cyclic process, that means it started, it came back to its original point. Okay, in original state. That is very important. It came to its initial state or the original state. Okay? Then we call the process called cycle, and you have to see in the cycle what kind of process it is. You have to look into that what kind of process it is. Now this is one of the key points. It has been explained. The change in the value of any property of a cyclic process is 0. Okay? Either it can be the pressure, that is, this is a closed integral. This a closed integral means the process is cyclic. Okay? The process is cyclic, or we can say cyclic or the closed system. Okay. So what is meant by closed system? There won't be any mass transfer. There won't be any mass transfer. The energy transfer can take place. Okay. Now come to the zeroth law. Now let's come to the zeroth law. Before that, I will highlight a few more things. Specific gas. Okay. So before you start your thermodynamics, you must know few formulas. Okay. Cv, okay, now is E plus 2 by N. Do you know these formulas? Okay. Please remember this formula. These are the specific heat of gases. The value for Cp for air is 1.005 kilojoule per kg per Kelvin. And C is 0.7.3. Then gamma equals to 1.4. Gamma is a adiabatic heat constant, or you can also call as a adiabatic index.
Excuse me, ma'am.
Yes.
It's actually the CV value is 717.85, isn't it?
Sorry.
CV value, ma'am.
Sorry.
Specific heat at the constant volume, ma'am. The CV value is 717.85.
It's 718.
Oh,
718.
okay. Okay.
Please keep that in mind. Okay. Alright. Now let's move to the zeroth law. Okay. So zeroth law, what I have said, it deals with the measurements of temperature. Deals with the measurements of temperature. Now, what kind of temperature? They have taken three bodies. Okay, they have taken three bodies, A, B, and C. Now, what it says, when the body A, okay, body A and B are in contact with each other, when A and B, when the body A and body B are in contact with each other, okay, if there is another third body, okay, which is also connected with the other body, then it says the temperature of A and temperature for B and temperature of C will be same. Okay? When A and B are thermally contact with each other and another body come in contact with any one of the body, it can be of with the A, it can be with the B, then we can say then this all these three bodies will be thermally will bring into a thermal equilibrium. They will be having the same temperature. Got it? Alright. Now we will move to the core and very important topic about the heat and work. Okay, we'll come to the very important topic is a heat and work. So so what is heat? The energy transfer across the boundary of the system because of the temperature difference between the systems and the surroundings. Okay? So if there is a container. If there is a container, okay, and I'm keeping a cold water, chilled water, okay, in that container, and outside the temperature is about 34 degree Celsius, okay, and here we have around 24. Let's consider this chilled will be around, consider 10. Let's consider 10. Alright. Now what will happen? How it will flow from high to low. It will try to maintain an thermal equilibrium, so it will move high to low. So it will get, the heat transfer will be taking place. So always the temperature will move from high to low. Okay. How it will move? If there is a temperature difference between the system and the surrounding. What is the surrounding? In the atmospheric condition is the surrounding. And what is the system? In a container, you are having your chilled water. That is the system. Okay. Now here in this, sometimes in the case ask such kind of questions, they will give you an example and they will ask you to identify which one is the system and which one is the surroundings. Okay. So just get prepared with such kind of question. Now here it is very important to understand how this heat is added to the system and heat is transferred to the system. Okay? How the heat is added to the system and heat is transferred to the system. Okay? Now before that, what is work? Work is also one of the mode of energy transfer. It is also one of the mode of energy transfer. Now here we will see, so what, when the work, we say that what is work? Work is done by a force, okay, when any kind of force is acting on a body, okay, it can be by means of external system or maybe by the heat transfer. It should be have some kind of force, moving force. Now we will see how the heat transfer and work done can be done by the system and done from the system. Okay. Now I hope you can see I have with the two different colors. When a system is there, when any system is there, when a heat is added, okay, when a heat is added to the system, that means the heat is entering. The heat is entering into the system, okay, that heat will have the positive value. The heat will have the positive value. Okay. Now the same thing when the heat leaves the system. Okay. When the heat or leave the system or leave from the system, it will be of, the heat transfer will be of negative. Heat transfer will be of negative. Okay? Please remember this convention. Okay? Remember the convention. Second, now what is the impact happens for a work done? Now when the work is done on the system, okay? Work done on the system. That means the work done is entering into the system. Okay? When it's entering into the system, we will have the negative value, that work done on the system. Now, when the work is leaving by from the system, okay, or by the system, work done by the system, that means it's completed, it's done, that means it will be positive. Now, these conventions are very, very, very important. Okay, these conventions are very important. All right. Did you get it? So when the heat is entering to the system, it should be positive, and work done by the system when work will be completed and done by the system, it will be positive. Just if you can remember like this figure, the positive, negative and all, then you can do it. Now what kind of question you can expect? Okay, there is any system will be given. Okay, now they will be giving you the problems like this. Now they will tell you, they will give the values alone. They will give the magnitude. Suppose this is a bottom 1, this is a Q2, this is bottom 2, this is bottom 3, this is Q1, and let me put one more, this is Q3. Okay, they will give you the magnitudes. They will give you the magnitudes in this kind of system. They said in the system there are 3 heat transfer and 3 work done. Now how you feel, how you come up? So again you have to apply the first law of thermodynamics, which will come up right now. So in the first law of thermodynamics, what is that? It is a closed system. In a closed system, it is uh, closed integral of dq, closed integral of dw. Now you have to sum up with that. So you can see it is entering, Q1 is entering, so Q1 positive, Q2 is leaving, that means negative, Q2, again Q3 is leaving, minus negative. Now if I want to look for the work done, let me write it over here. I can say that W1 is done by the system, so it is positive. Then again work done, uh, Q2 is, sorry, W2 is again leaving, so again it is positive. Then W3 is entering, so we will have, it is negative. So maybe by the system you can find out what is the work done and how much amount of work transfer. Alright, magnitude is very important to understand the magnitude. Now I will come to the path function and point function. Now what is the difference between path and point? Okay. Now here you can see the graph has been shown over here. The path means it depends, suppose one process is undertaken. Suppose one system is there, some kind of process. Whatever the process, some process has been taken. It is not important what process here, but some process has been taken. So which is moving from the initial state, that is 1, and the final state is 2. Initial state is 1 and the final state is 2. Initial is 1 and the final state is 2. Now it can possibly from one state to another state, it can go in a different way. Which way? Which path it can go? It can follow this process A, it can follow the process B, it can follow the process C, and many more additional processes are quite possible. Even this kind of process is possible. Now in the path function, okay, how this path are defined, it depends, the path is dependent with the which process it has been followed. Based on the process, the path get decided. As I mentioned earlier, it is not important the initial, what is the initial state and the final state. It only depends on which process, whether it is an isothermal process, whether it is a polytropic process, adiabatic process, isochronic process, isobaric process. It depends only with the process. Okay, so whatever the functions, it depends with respect to the process. Such factors counts on the path function. who is not dependent on the initial states, which is not dependent with the initial and final state. Just not dependent. They are only dependent with the which process has been followed. Okay. So I think I've written it's not a function of end process. End process means what are the initial and the final state. Okay. So such kind of process, suppose the work is done within the 1 to 2. Okay, work is done in the process 1 to 2. So we can write how we can find the work done. To change in work done, integral 1 to 2. It's moving from the path initial path 1 to 2. So we can write the work done 1 to. We cannot write W2 minus W1. We can't write, okay, this is, we can't write W2 minus W1, we can't write it. This means we can write only when we define the initial and final step, which is irrespective of the process, who only focus on the initial step and the final step, who doesn't bother with the path or process. Such parameters is called as a point function, okay, which is dependent with the points, that is the initial point and the final point. So such functions will be dependent with the point function. For an example, it is an enthalpy, okay, enthalpy, maybe your internal energy, which depends on point function. Path function, if I say, it will say about the amount of work transfer, amount of heat transfer. Work transfer and heat transfer defines a path function. Okay, but apart from that, enthalpy, internal energy defines the point functions. Okay, so it says that this is another important thing. W, that is a work done, is an inexact and indifferential. That means we cannot differentiate this in the path function. But this opposite thing happens in the point function. Just the opposite thing happens in the point function. As I've said, here we can differentiate. The work done is exact and perfect differentiable. We can differentiate the state, from which state it moved from which point to which point. Did you get it? Now we will move to the next is work done. Okay. There was a problem. Solve it. Now let me explain you what is the first law of thermodynamics. Then we will move to the work done phenomenon. So first law of thermodynamics, what it says, the energy can neither be created nor be destroyed, right? So in that, it is only satisfied only when it will be in the cyclic process or the closed system. Okay, either it is a closed system or the cyclic process. Cyclic process means again both are same. So when I'm talking about cyclic process, that means heat will be transferring, but the mass transfer can't take place. Keep that in mind. Now remember this problem. Remember this formula. I hope already we have discussed this formula, right? These are the closed integral means you can also write like this formula. You can write this formula. All are correct. Okay. Now here, when we want to now how from where this internal energy came? Can anybody unmute yourself and say how this internal energy came? Now we were discussing about that how this internal energy came.
It's actually the energy that's stored within the body, mom. Internal energy.
Yes. Internal energy is stored in the body. Only one person is speaking. What about the others? It's a very
Ma'am,
basic question.
then,
It's not audible.
ma'am, the energy which is used to done by the, to do the work, ma'am, means which is lost by the body or which is stored by the body.
Okay. What about the others? Now, previously I have said that Q is equals to the work done. Now I am telling this equals to some kind of internal energy. Right? I'm telling it is some kind of
Ma'am, every time the 100% work is not done by the whatever we give the energy, no, ma'am. So that means whichever energy that will not convert into work, that is you, ma'am.
Which
that
means
is the
like the heat dissipation, mom. That's nothing but the loss of heat that is there in the system is called as
yes, that is actually the loss.
difference.
Okay, so that's what the loss, why the loss is occurring. That is a loss, that is energy absorbed by the molecules. Energy absorbed by the molecules. That is called as the internal energy. Alright, that is a loss, as you said. Why the losses is taking place? Because the energy absorbed by the molecules. So in this case, what we do, we can also write like that: Q minus W equals to some change in internal energy. We always write del U or del U, or some text we can find even del E has been given. That means some amount of energy has been absorbed. Okay, so even if they had given you some kind of this kind of problems, okay, so using the first law of thermodynamics, if they ask you to find out the internal energy, if they ask you to find the internal energy, suppose this is a problem. Just imagine this is the Q2, this is Q1, then Q3, this is in this case, okay, the question is that they have asked to find how much in internal energy. What is the internal energy? How will you find what is the internal energy for this particular system? What is the internal energy for this particular system? So you have to write Q1 is going outside. That means it is minus. Then Q2 and Q3 is entering. Q2 and 3 have the minus. Then Q1 is again going out, that is a positive. Q2 is leaving by the system, done by the system again, positive. W3 is positive, W4 is negative. Will be, got it? Keep that in mind. We always don't write complete U or E, okay? Whatever it is, complete U or E. Okay, because here we are only talking about only change in energy. Okay, so they might confuse you in the question. A very simple question they can ask. They can give you lot many options like that. Okay, maybe they can give. I've seen one of the gate question. They have asked like this. One option like this. Second option was all Q, W, and U. Third option was now tell me which one is a correct. Which one is correct?
Fourth one, ma'am.
Fourth one.
Fourth one.
All of you agree that the same? Fourth one is correct. See, this is a very simple question, isn't it? It's a very simple question, but
Hello, ma'am. Are you speaking, ma'am? Hello.
Yes, she has been disconnected. Hello. Hello,
now similarly talking with that same, there are some, as I've said, if I talk about energy here, okay, internal energy is an extensive property. Now, just recalling that here, internal energy is an extensive. What is mean by extensive? Where it is dependent on the mass. But if I talk about specific energy, okay, whenever I'm talking something specific, it becomes a intensive. Okay, this extensive that becomes intensive. Reason specific energy. Again. Now clear with the first this thing. Okay. Now we will move the equivalent amount of work done. Now we will move to the work done part. And then we will solve some of the problems. So, yes,
today till what time we are having the class now?
till 10 o'clock.
Okay.
It was 8 to 10. And today we have one more sessions, okay? So, we have some ISRO scientists who will be taking the orbital mechanics, okay? So, let's come back to here. Now, work done. Before talking about work done, keep that in mind there are lot many types of work done. Two types of work done. One can be of non-flow work done and there's a flow work done. Okay. Non-flow work done means the it is a reversible process. Okay. It is a reversible process which will come back to the original state. It will come back to the original state and flow work done will be your and flow work done will be your irreversible process. Now, first we'll move.
Mom, can you tell the point again, Mom? Sorry, the last point I could not hear properly.
Okay, we have two types. One is an non-flow work done, and second one is a flow work done. Okay, the flow work done means it is moving from one point to another point. There is no way come back. There is no way to come back. Okay, but in non-flow work done, there is a reversible process. If it go back in this path, it can come back on other path. Okay.
Okay.
If it go by this path, it can come back in other path. So when we are mentioning that, I think I have mentioned over here. It is reversible, irreversible, and all I have mentioned over here. So you can see first we will look about the non-flow process, which is a reversible process. When we talk about the non-flow work done, okay, that means it is not flowing from one point to another point. It can also has a capability to come back. That is a non-flow work done. So now we will see some of the processes on the non-flow work done. Okay. So first we will see the isobaric process. Okay. So sometimes they may not mention you the isobaric. They can use a different term. Okay, isopistic process. Okay, isopistic process is also known as a isobaric process, which is with a constant pressure process. Okay, is a constant pressure.
Is it isospastic?
Huh? Pistic, pistic, pastic, however you pronounce. Now, when we plot a graph between P versus V. V is the volume, V is the pressure. The pressure is constant, it is moving from one point, initial point is 1, point is 2. I request please to kindly mute yourself. Alright. So here in this kind of process, okay, this is a non-flow process as I've said. So in non-flow process, we define the work done like W1 to 2, that is the process is moving from 1 to 2. Okay? Because we cannot write W1 minus W2. I hope you remember that. Why?
Excuse me, ma'am.
Yes.
The whiteboard is not visible for me, ma'am.
It is not visible for anyone of you. Uh, just give me a moment. Right. It is quite right. Disconnected. Now is it visible?
Getting loaded now. So I'm able to see a PPT.
Just a minute. How about now?
No, it has come out of it. I'm able to see already. Welcome to big blue button. That's all.
Can you see right now?
Yes, ma'am. I'm able to see a PPT, ma'am.
This slide. I hope you can see it clearly now.
Yes, ma'am. It's visible.
Alright. So here the work done we can write 1 2. We cannot do we cannot write W1 minus W2. Why we can't write W1 minus W2?
Because it's a path function, ma'am.
because, very good, it is a path function. Okay, we can write W1 minus W2, we cannot write, but there are, if there is a your internal energy, we can write like this, or if there is entropy. Okay, if there is entropy, entropy is also a point function, so in that case we can write this. Okay, entropy is also, please note that the point, entropy is also a point function, keep that in mind. So you can expect such kind of questions. Please all of you note down the point, entropy is also a point function, so point function. So all right, now coming here, so this is a form for this, that is W dw integral p dv. Okay, here we will use, there will be a change in volume. Okay, pressure, that is a, what is a pressure? It is an intensive property, and volume, which is an extensive property, which will be changing and which will create, or which will help to create an reversible process, or if you can say as a come back to the original state. Keep that in mind in case of non-flow work. This is the formula, and if we are doing foreign flow work, the formula get changed. Okay? That time V become constant and P changes. Okay? That time in non-flow work, since that is a control volume, that means the volume is fixed. Okay, that's why it is also known as a control volume. The volume is fixed. That time there will be change in an intensive property. So this is also, you can expect this question. You can also expect this question. Please keep a key point. Yes, you can see I have noted the formula over here. This is also an important key points. Here this is an extensive property which is fixed since it is a control volume process. Okay, and here there will be a change in okay. So let's come back to here. So now here I'm not going much deep with the derivations. Okay. Now what you have to do, you have to remember the formula. Remembering the formula is a prior thing. So here you can, I think this is not a big sort of formula, so you can remember, right? So whenever there is a isobaric process, okay, isobaric process, this is, remember, this is a formula for a non-flow work, or it is a reversible process. Okay. On that time, what is the formula for an isobaric? P is constant, then the volume is changing from one state to another state. Just give me a moment. Alright. So moving to the next is a isotonic. Isotonic means where the volume is constant. So change in volume, if the V1 is equals to V2, okay, then obviously V1 minus V2, when you substitute, it will become 0. And simultaneously remember the graph. Always I say remember the graph. So for constant pressure, there is a horizontal line. For constant volume, is a vertical line when it is plotted between the P and V. Third one, we have the isothermal process. Okay, isothermal process, we have this PV equals to C. When you solve that, you get this value. Now, as of yesterday, I think day before yesterday, when we are solving the problem, and some of you tried to find out with a V2 by V1, then finally I have, when I was equating the value P1 V1 equals to P2 V2, the value what they have given, it was not equating in fact. Okay, it was not even equating. So I think there is some error with that values. Okay, wherever we have given that values, it has been there is some error. Okay, so it has to be forming that value. Okay, so uh, so what you have to do, suppose in this kind of cases it happens, I hope this doesn't happen during the exam, so do not get panic. Okay, just try to figure out whether P1 V1 equals to P2 V2. There are some questions they used to have in the gate, like there are some errors, some values are missing, so they used to give you the bonus marks for that particular question. Okay, so that is not a big deal. All right, so they used to provide you the bonus marks in that case. So we will see some of the some problem today about the isothermal process. Okay, so remember the formula as I've said. Remember for the isothermal, that is PV. You can remember the P, all are one over here. So there will be some ln P1 by P2. And you know this formation P1 V1 equals to P2 V2. If I am having P1 by P2, that means we'll have the V2 by V1. So obviously, if P1 V1 ln V2 V1 will be the another formula. The small facts you have to remember. Now moving to the next is that the next is a adiabatic process. Okay, then we can move to the adiabatic or polytropic process. Polytropic process or adiabatic process. Let's consider in the adiabatic process, instead of gamma, we have taken some power in. Okay, power in. So when we are taking some power, that means polytropic means we are changing the property. Instead of air, it can be anything. It can be pressurized gas. It can be a steam. Okay, so we are just taking the kind of any other flow, okay, which can change its property based on the heat transfer. So PV power N equals to C. Okay. So here when you do polytropic or adiabatic process, okay, polytropic is a general formula. Using that, remember this formula. Remember this particular formula. Remember this formula. That is P1 V1 minus P2 V2 divided by N minus 1. Now, how sometimes you might get confused that whether it is 1 minus, whether it is 1 minus N or N minus 1. That is a very common problem that most of you guys face this kind of problem. Now, how to recover from this kind of problem? Okay. Now, what you can do is always remember the N value. Whatever the N value we have is always more than 1. It's always more than 1. Okay. Keep that in a point. N is always greater than 1 or equals to 1. It cannot be less than 1. So, you don't want negative in your formula. So, or in your answer. So, you will have N minus of 1. So, this is how I used to remember, like, okay, it cannot be N, cannot be negative. So, N minus of 1. Because sometimes when you start solving, it can be a confusing thing. Okay? So, always keep some small hints to avoid such kind of mistakes. So I hope you remember the formulas. Let's solve one problem. Okay. Now this is the same thing. Now please ensure that there is some error, typo error. It will be temperature when n equals to 0. That will be a constant pressure. N equals to 1 is a constant temperature. When n equals to, that is adiabatic index, we have the reversible adiabatic process. When n is infinite, we have the constant volume. Okay, and sometimes they might give you some kind of process, and they might ask you to find out the work done. And another way to find out the work done, to find out the area of the process. To find out the area of the process will give you the work done. So based on this four different process, we can say that isobaric process, the work done of an isobaric process will be greater than isothermal, greater than diabatic process, greater than isothermal process. Remember, already I have asked the question. So again, it can ask in the ascending or the descending orders. Okay, ascending or the descending orders. You can ask. Now let's move to the first problem. Okay. Now move to the first problem. Now, what is they have asked? A mass M, okay, mass 1.5 kg of air is compressed in an quasi-static process from, that is, what is this? They have not mentioned anything. What kind of? So I have to see the unit. That means compressed what? That means pressure. From, that is P1 M, that is a megapascal to 2. Okay, it is 0.7 megapascal, for which PV equals to constant. Now, what is that means? The PV equals to constant, which process? When you have PV equals to constant, when you is very good. When that means this is a question from an ISO.
You're not audible. Hello? Friends? Hello? I'm there. Hello? Can anyone speak?
Ma'am is left, bro.
Left. Okay. You solve, bro. Getting answer negative.
Hello, ma'am.
Hello, Abhijit.
Bro.
Bro, what
Hello.
happened? Not there.
Don't know, bro. What happened?
She's coming.
Hmm.
I think I have been disconnected because of the internet issues. How long I have proceeded? Can you see the PPT again?
It's getting loaded now.
Loading.
Okay. Once you can see, let me know.
Yeah, ma'am, you are audible, but screen is not visible, ma'am.
Still not
Getting
visible.
loaded now.
Okay.
It's getting loaded.
Let me. Okay, what I do is again I will rejoin the session. Okay, I will cancel off and rejoin the session.
You're audible, ma'am.
But still something shows that it is sharing.
For that problem, got the answer in negative, ma'am.
You're getting negative. I've given the answer in that, right?
Yes, ma'am. Magnitude is matching, ma'am, but not the sign, ma'am. Sign is getting inversed.
Negative? How? How you're getting the negative sign?
No, ma'am, positive sign only I am getting.
There is some issues is happening. Can you hear my voice clearly? It is clear, right? Or it is creating kind of glitch. Just give me a moment. It is loading. There are a lot many pages. It is still processing because I'm trying to share the page in a different way. I think I'm unable to share this thing. I don't know why. What is the problem?
Once again, rejoin, ma'am. It will.
Okay. Let me do the same because it just keep on loading. It is showing that I'm sharing some kind of presentation. It is already showing something like that. So what I'm doing is, let me end the session. Okay, let all of you again rejoin it. Okay, let me try in that way. Is it okay? I'm
Okay,
ending.
ma'am.
Okay, all
Yes,
right.
ma'am. We will rejoin, ma'am. We'll rejoin.
I'm ending the session and let me rejoin it again. now it is visible to all of you.
Yes, ma'am. It is visible.
All right. So, see, I have written here, I have completed till here. V1 you have to find by mass by, you have to use mass by density, because here they have given the mass and density. Then after that, whatever the value will you get, you need to substitute over here. P1 is known to you, P2 is here known, it is 0.7, this is 0.1, 0.7, 0.1. Alright, so after that you will know what is the work done. Alright, so I hope you are getting the same answer.
That's what, mom. I'm getting the same answer, mom, but with the minus sign I'm getting, mom. I don't know why.
How? Okay.
Because 0.1 by 0.7 will be getting as minus 0.1428, and then the ln of the answer is going to be minus 1.945. There comes the minus sign, mom.
Okay, you have what is the value? There is a 0.1 into 1.29. You have something got like that.
1.293, mom.
7. Let me try.
0.1428, mom. That
Okay.
ln of.
You can try. 7. Then we have to use.
Ma'am, I am also getting the minus answer, ma'am.
Okay. Alright. Minus sign is coming. 0.3 into 0.1. Yes, because when you're doing the ln, you're getting minus. Right?
Yes, mom.
Minus of same answer,
Yes,
right?
ma'am.
Minus of the
Yes,
same
ma'am.
answer. Magnitude is same.
Okay. Alright. No problem. Okay. Magnitude is only, answer is same, magnitude is different. Now let's try for the next problem and let me know the answer. Let's try for the next problem. A mass of gas is compressed in a quasi-static process. Again, they have given the pressure, that is V1, then volume V1 is given, and 2 V2, V2, it is 0.4 megapascal, then 0.03 meter cube volume. Assuming the pressure and volume are related with PV power n equals to constant. That means it is an polytropic process. Find the work done by the gas system. Work done by the gas system. Find out and tell me the answer. So what is the formula I have said? Work done for this process, P1 V1 minus P2 V2 by n minus 1. Always n will be first, then it will come minus 1. Now all the values are known. How will you find n? There is a formula to find n. Ln P2 by P1 divided by ln V1 by V2. This is a formula to find out the power n. Okay, please use the formula and find out the answer.